Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to f of y plus phi of x plus y plus z by eliminating the arbitrary functions f and phi. We are given a relation and we are asked to form a partial differential equation by eliminating this f and phi, which are arbitrary functions. So let's see. Given z equal to f of y plus phi of x plus y plus z, consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating one with respect to x. Just apply dou by dou x on both sides of the equation or do directly, okay? In order to avoid mistakes, we can just apply dou by dou x on both sides of the equation. If you are really good at partial derivatives, you can just skip the steps which are avoidable. Fine. Now, this gives us dou z by dou x equal to partial derivative. Here we are partially differentiating with respect to x, so we will treat y as constant. So here f of y is treated as constant. Partial derivative of a constant with respect to x is 0 plus partial derivative of phi of x plus y plus z is phi dash of x plus y plus z into inner derivative dou by dou x of x plus y plus z. Right? This gives us, we have a notation dou z by dou x equal to p. Just replace dou z by dou x by notation p. You will get p equal to phi dash of x plus y plus z into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus partial derivative of z with respect to x is dou z by dou x. Again replace it by p. Then you will get p equal to phi dash of x plus y plus z into 1 plus p, right? Consider as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou y on both sides of 1. This gives us dou z by dou y equal to partial derivative of f of y with respect to y is f dash of y. Here we are partially differentiating with respect to y, so we will treat x as constant plus here you will get inner derivative, that is dou by dou y of this y, okay, plus partial derivative of phi of x plus y plus z with respect to y is phi dash of x plus y plus z into inner derivative dou by dou y of x plus y plus z, right? This gives us, since we have a notation dou z by dou y equal to q, let's replace dou z by dou y using the notation q. You'll get q equal to f dash of y into partial derivative of y with respect to y is 1 plus phi dash. It's not necessary to write, okay, just for the clarification I'm writing this. It's not necessary to write, okay, plus phi dash of x plus y plus z into partial derivative of x with respect to y is 0 plus partial derivative of y with respect to y is 1 plus partial derivative of z with respect to y is dou z by dou y, which can be replaced by the notation q. So this gives us q equal to f dash of y into 1 is f dash of y plus phi dash Phi dash is nothing but phi dash of x plus y plus z into 1 plus, just replace this by a notation q. Okay, and consider it as equation number 3. Fine. See, by partially differentiating 1 with respect to x, we got equation involving p. By partially differentiating 1 with respect to y, we got equation involving q, right? Now let's find equation involving r, p if necessary, s. Okay, let's see them also. We got equation 2 and 3, right, which involves p and q. We know that this p is nothing but dou z by dou x and q is nothing but dou z by dou y. Instead of taking p, you can write dou z by dou x. Likewise, instead of taking q, you can write dou z by dou y. Okay, fine. Now, we'll find the equation involving r. R is nothing but dou square z by dou x square. Or we can write this as dou by dou x of dou z by dou x. We know that dou z by dou x can be replaced by the notation p. So partial derivative of p with respect to x gives r, right? Now, in order to find equation involving r, what you have to do is just observe the equation involving p. So this is the equation involving p, right? Now, by differentiating this equation with respect to x, that is partially differentiating equation 2 with respect to x gives the equation involving r. So what we have to do now is we have to partially differentiate equation 2 with respect to x. Partially differentiating 2 with respect to x. So here, instead of taking p, I am going to take dou z by dou x. So I'll get I'm just taking dou by dou x on both sides of this equation. Okay. Fine. So here we are partially differentiating with respect to x. So we'll treat y as constant. For your convenience, write this p as dou z by dou x. Okay, fine. This gives us dou square z by dou x square equal to, here you're having two terms, right? U we consider it as uv and apply uv whole prime formula, which is u dash v plus v dash u. Here instead of writing p, you can write dou z by dou x for your convenience. Okay, fine. Now you can write this as partial derivative of first term into 1 plus p. Let's write 1 plus p here. We can change this later as dou z by dou x. Let it be p plus phi dash of x plus y plus z into dou by dou x of 1 plus p. See here, yeah, let it be, or you can just write dou z by dou x. Okay, because here we are going to find partial derivative of this term, right? Since we know that dou square z by dou x square equal to r, let's replace the LHS part by r. You'll get r equal to partial derivative of phi dash of x plus y plus z is phi double dash of x plus y plus z into inner derivative, that is dou by dou x of x plus y plus z into 1 plus p. Okay, plus phi dash of x plus y plus z into partial derivative of 1 with respect to x is 0 plus dou by dou x of dou z by dou x is dou square z by dou x square. Okay, in order to write dou square z by dou x square directly here, I just wrote p as dou z by dou x. Okay, instead of writing p, I wrote dou z by dou x. Okay, if you write p, what you'll get here is dou by dou x of p. You'll write it as this, and in the next step you'll convert it as r. I mean, you'll change it as r. Okay, so instead of writing p, I wrote dou z by dou x just for our convenience. You can also write it as p. Fine, now this gives us r equal to phi double dash of x plus y plus z into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus partial derivative of z with respect to x is dou z by dou x, which can be replaced by p here, into 1 plus p plus phi dash of x plus y plus z into r. Right? Fine. Now this gives us r equal to phi double dash of x plus y plus z into 1 plus dou z by dou x can be replaced by p, since we have a notation. So we'll use that notation, into 1 plus p plus r into phi dash of x plus y plus z. Okay, now you can write this as r equal to phi double dash of x plus y plus z into 1 plus p whole square plus r times phi dash of x plus y plus z. You can consider it as equation number 4, or bring this term to LHS and take r common from it. If you'll bring this to LHS, you'll get r minus r times phi dash of x plus y plus z equal to phi double dash of x plus y plus z times 1 plus p whole square. Now take r common here, you'll get r times 1 plus phi dash of x plus y plus z equal to phi double dash of x plus y plus z into 1 plus p whole square. Okay, instead of doing this, consider this equation as equation number 4. If you're not that good at these problems, just consider it as equation number 4. Okay, we'll use this further. Right, I just wanted to show you here, so I just continued for next 2 steps also. Consider this equation as equation number 4. Okay, if you have practiced number of problems, then already you have few of you guessed this, right? I think if you are really good at solving these problems, you will understand why we have written this equation like this. Right? Fine. Now we'll find the equation involving t. Right. Now we'll find equation involving t. You know that t is nothing but dou square z by dou y square, right? We can also write this as dou y of dou z by dou y. And we have a notation dou z by dou y is q. Let's replace it by q. You'll get dou q by dou y, that is partial derivative of q with respect to y is our t. So in order to find equation involving t, observe the equation involving q. So here is the equation involving q. Now by partially differentiating it with respect to t gives the equation involving t. Okay, by partially differentiating equation involving q with respect to y gives the equation involving t. Now what we are going to do is we'll just partially differentiate equation 3 with respect to y. Partially differentiating 3 with respect to y. Now here what I'm going to do is, instead of taking q, I'll take dou z by dou y. Okay, and I'll apply dou by dou y on both sides of equation 3. Dou by dou y of dou z by dou y equal to dou by dou y of f dash of y plus phi dash of x plus y plus z into 1 plus q, right? This gives us dou square z by dou y square equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. Okay, fine. Now, partial derivative of f dash of y with respect to y is f double dash of y into inner derivative dou by dou by dou y of y plus partial derivative. Here you're having two terms, right? So we'll apply uv whole prime formula. We know that uv whole prime equal to u prime v plus v prime u. Just apply this formula to this term. We'll get 1 plus q into dou by dou y of phi dash of x plus y plus z plus phi dash of x plus y plus z into dou by dou y of 1 plus q. Here you can write q, or you can write dou z by dou y. Instead of this q, you can write here dou z by dou y. It makes easy, right? Fine. Now let's see what happens here. This gives us, since we know that dou square z by dou y square equal to t, just replace this term by t. You'll get t equal to f double dash of y into partial derivative of y with respect to y is 1 plus 1 plus q times partial derivative of phi dash of x plus y plus z is phi double dash of x plus y plus z into inner derivative, that is dou by dou y of x plus y plus z plus phi dash of x plus y plus z into partial derivative of 1 with respect to y is 0 plus partial derivative of q with respect to y is dou q by dou y. Dou q by dou y is nothing but dou by dou y of q. Again, q is nothing but dou z by dou y, which gives us dou square z by dou y square, right? So here, instead of writing q, if you write dou z by dou y, here itself you can write dou square z by dou y square. Okay, there's nothing wrong in it. You can write q or dou z by dou y. Okay, it's up to you. Now this gives us t equal to f double dash of y into 1 gives f double dash of y plus 1 plus q times phi double dash of x plus y plus z into inner derivative partial derivative of x with respect to y is 0 plus partial derivative of y with respect to y is 1 plus partial derivative of z with respect to y is dou z by dou y, which can be replaced by q, or you can write just q here. Instead of writing dou z by dou y, you can write q directly here, or you can write what you have. It is dou z by dou y. Okay, plus phi dash of x plus y plus z into dou q by dou y, just nothing but dou square y by dou y square, dou square z by dou y square, which is t. You can just replace this by t here. Okay, fine. Now this gives us t equal to f double dash of y plus 1 plus q into phi double dash of x plus y plus z into 0 plus 1 1 plus We can replace it by q, since we have a notation q, plus phi dash of x plus y plus z into t. Okay, or you can write this as t equal to f double dash of y plus phi double dash of x plus y plus z into 1 plus q plus 1 plus q gives 1 plus q whole square plus phi dash of x plus y plus z into t. Consider it as equation number 5. Okay, and if you can bring this to LHS, you can take t common. That gives us t times 1 minus phi dash equal to f double dash plus phi double dash into 1 plus q whole square. Okay, if necessary, we'll use it for further. We'll see that later also. Okay, let's not rush. Let's observe slowly. Now let's find, yeah, you need to observe all the equations, right? 2, 3, 4 and 5. I think these equations are not necessary, not enough. Not enough to find the required partial differential equation, because here you are having f double dash of y, phi double dash of y, phi double dash, phi dash, and in R you have phi double dash, phi dash, f dash, phi dash, phi dash, right? You don't have any f double dash, right? So it's not possible to eliminate f double dash. So let's go for s also. We'll find equation involving s also, because the equations which we are having are not enough to find the partial differential equation. Right? Now, we know that s is nothing but dou square z by dou x dou y. We can write this as dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x. We have a notation dou z by dou x equal to p and dou z by dou y equal to q. We can just replace dou z by dou x by p, which gives us dou p by dou y here, or yeah, here when it comes to dou by dou x of dou z by dou y, you can just replace it by q, which gives us dou q by dou x, right? So in order to find equation involving s, you can consider this or this. If you want to find equation involving s with the help of equation involving q, what you have to do is, we can just partially differentiate equation q, equation involving q with respect to x, or we can pick equation p, and by partially differentiating equation 2 with respect to y gives equation involving s. You can go for this or this. Okay, so let's try for, let's try for q. What's wrong in it? Let's try for q and see what we are going to get. Okay, so here what we have to do is, we have to partially differentiate equation 3 with respect to x. So instead of taking q, I'll write dou z by dou y. Okay, now we'll partially differentiate three with respect to x. So instead of taking q, I'll take dou z by dou y, and I'll partially differentiate with respect to x. Just take dou by dou x on both sides of equation 3 simply. Right, fine. This gives us dou square z by dou x dou y equal to, here we are partially differentiating with respect to y, so we'll treat y as constant. Here we are partially differentiating with respect to x, so we'll treat y as constant. So here f dash of y can be treated as constant and you'll get partial derivative of f dash of y with respect to x is 0. Plus here you're having two terms, so we are going to apply uv whole prime formula. Dou by dou x of phi dash of x plus y plus z into 1 plus q plus dou by dou x of 1 plus q into phi dash of x plus y plus z. This gives us, we have a notation, since dou square z by dou x dou y equal to s, let's replace the LHS part by s, so that you'll get s equal to 1 plus q into partial derivative of phi dash of x plus y with respect to x is phi double dash of x plus y plus z into inner derivative dou by dou x of x plus y plus z plus phi dash of x plus y plus z into partial derivative of 1 with respect to x is 0 plus partial derivative of q with respect to x is dou q by dou x. Dou q by dou x is nothing but s, right? This gives us s equal to 1 plus q into phi double dash of x plus y plus z into partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0 plus partial derivative of z with respect to x is dou z by dou x, which can be replaced by p, or just write dou z by dou x plus phi dash of x plus y plus z into dou q by dou x is nothing but dou by dou x of q. Q is nothing but dou z by dou y. Can write this as dou square z by dou x dou y, which is s, right? Since dou square z by dou x dou y equal to s, right? So this gives s. I'll write s simply. This gives us s equal to 1 plus q. Here, instead of writing this step, you can just write 1 plus q whole square into phi double dash of x plus y plus z, because we are having dou z by dou x, right, which can be replaced by the notation. Yeah, it's dou z by dou x, right? Okay, you can't write it as q because it's p, right? So you can just write 1 plus q plus 1 plus p into phi double dash. Okay, it's not 1 plus q whole square. You can write 1 plus q into 1 plus p into phi double dash directly, or you can increase one more step. If you have patience, you can just do it. Since dou z by dou x equal to p, you can just replace it by p plus s into phi dash of x plus y plus z, right? And this gives us s equal to phi double dash of x plus y plus z into 1 plus p into 1 plus q plus s times phi dash of x plus y plus z. Consider as equation number 6. Very fine. Now observe yeah, let's see what to observe. So here observe all the equations. In the first equation you have, in equation 2, phi dash. Here you're having f dash phi dash, phi double dash phi dash, f double dash phi double dash phi dash, phi double dash phi dash. So in these two equations you have phi double dash and phi dash. Can we eliminate phi double dash and phi dash from these two equations and form a partial differential equation? Question mark. We have to think about it. So what we are going to do is, we'll just consider equation 4. Okay, consider equation 4. From equation 4 we have I'm just writing equation 4, okay? It's phi dash. Right. Bring this term to LHS, you'll get r times, let me write one more step, there's nothing wrong in it. Equal to phi double dash of x plus y plus z into 1 plus p whole square, right? If you take r common, you'll get r times 1 minus phi dash of x plus y plus z equal to phi double dash into 1 plus p whole square. Let it be. Now, consider equation number 6. We have equation number 6, that is s equal to phi double dash of x plus y plus z into 1 plus p into 1 plus q equal to s times phi dash. Now, bring this term to LHS, you'll get s minus s times phi dash equal to phi double dash of x plus y plus z into 1 plus p into 1 plus q, right? Very good. Now let's take s common here. You'll get s times 1 minus phi dash of x plus y plus z equal to phi double dash of x plus y plus z into 1 plus p into 1 plus q. If you observe these two equations, we can say that using this divided by this, we can eliminate 1 minus phi dash and phi double dash, right? Which gives you the required partial differential equation. Let's consider this equation as equation number 7 and this one as 8. Now let's try 7 by 8. LHS of 7 is r times 1 minus phi dash of x plus y plus z by LHS of 8 s times 1 minus phi dash of x plus y plus z equal to RHS of 7 phi double dash of x plus y plus z into 1 plus p whole square by RHS of 8 is phi double dash of x plus y plus z into 1 plus p into 1 plus q, right? So here you can cancel 1 minus phi dash and phi double dash and 1 plus p. Okay, here you can write 1 plus p whole square as 1 plus p into 1 plus p. Otherwise, here you're having 1 plus p whole square, right? You can write this as 1 plus p into 1 plus p, where 1 plus p gets cancelled from the numerator and denominator as well, right? And this results to r by s equal to 1 plus p by 1 plus q. Now make a cross multiplication to simplify it. This gives us r times 1 plus q equal to s times 1 plus p. Okay. Which is a required partial differential equation. Or you know that r is nothing but dou square z by dou x square into 1 plus q is nothing but dou z by dou y plus s is nothing but dou square z by dou x dou y. It's equal to, right? It's not plus, it's equal to into 1 plus p is nothing but dou z by dou x. This is the required partial differential equation. Therefore, r times equal to s times is the required partial differential equation. which completes the problem. So in order to get a grip on this concept, you need to practice well. Okay. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.